Buddy, this is lesson 2-2 for Algebra 1. Happy Thursday. All right, we're going to start off with where we left off the day before with our ice cream party. Okay, as a reward for achieving our goals, now we're instead of a pizza party like it was yesterday, we're doing an ice cream party. Write an expression that could represent an estimated cost for the party. Use at least one letter. State what each part of the expression represents. Okay, for me, I'm going to go simple as possible. We're going to use an F. Okay, an F. And down here, we'll go ahead. The F equals the number of freshman students, right? Okay, and then we're going to take that times C. C, for me, is the cost of an ice cream per student. Okay, and then that's going to equal T. I know that is pretty straightforward, but for me, that is all I am going to do. Okay, F times C equals T. And so that could be the cost of an ice cream sandwich, anything like that. But if we have that set thing where, hey, similar to the ice cream social that we did, we use those little cups. Hey, here's the cup of an individual ice cream. We take that times the number of students, and we know how much we're going to spend on the little cups of ice cream. All right, now we're going to choose a letter in your expression to describe the values that would be reasonable for the quantity that letter represents. Okay, so let's go back. All right, we had F times C equals T. All right, so for us, let's pick C, the cost of that ice cream. Okay, you're going to pay anywhere for one ice cream. What do you think? It could vary, right? So for C, let's just say that we know it's probably going to be at least $1, right? So it's going to be greater than $1, the cost of an individual ice cream. But for me personally, if we're going to buy them for everybody, that's got to be less than, $2 is the max I'm going to say. So let's say that it's going to be then less than 3. So C is going to have those constraints that it's greater than $1 a piece, but it's going to be less than $3 a piece. Okay? All right, let's do some mental math. 25% of 200. We do that mentally. Okay, I'm going to come over here and 25% of that. We know that that's a quarter of 200. So a fourth of 200 is 50. 50. Then we come over here and we say 12%. All right, well, we know that 10% is 20. We know that 1% is 2. If we did it like that, it's 24. Or if you notice that, hey, 12% of 100 is 12, right? 200 would be basically saying, hey, I'm going to double that. So notice how we had 25 and 50, 12 and 24. So automatically then if we have 8, 8's going to be 16. And now we have P% of 200 mentally. And so what some people are going to say is, how would I put that? How would I put that? Okay, and so you could say, hey, we've been saying it's this times 2, right? The percent. So it'd be 2P. 2P. Or, if we do it just like we know, if we make that into a decimal, all right, we turn a fraction into a decimal by taking that P, dividing it by 100, and then multiplying it times 100. Or I'm sorry, 200. Okay, to find that 200%. So you can see here for me, I did a quarter here. I found out what 10% was and then added 2 1%. Here, if we know what 1% is, okay, we can take that. But for me, it was easy just to say, hey, 200 is double of what 100% was. So 25, 50, 12, 24, 8, 26. It always increased by 2. All right. Now with the split screen, this is a little difficult to see, but we've got a tetradon, a cube, and uh, well, a ball there. I'm not going to try to say that. I'm going to get it incorrect. All right. So what we know here is, what ways are the three figures alike? Well, they're all 3D shapes, right? They all have sides. They all have angles. They all have vertices. What ways are they different? They have the number of sides. Could be the number of vertices. Okay, and just their overall shape. So now let's look at this. So a cube. So here's our cube. And we say, how many faces does a cube have? So the flat faces here. So we know that there's 4 here, 1 on top, 1 on bottom. So there is 6. Okay, we come over to the cube. I'm sorry, its vertices. All right, and with here we say 1, 2, 3, 4. Oh, vertices are the points here. So I count my points: 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. And then when we look at its edges, where this part right here, well, I know I've got 4 here, 5, 6, 7, 8 there, but then I also have another 4. So I have 12. Okay? So we come here and it says make 2 at least observations about the number of faces, edges, and vertices in these platonic solids. Okay, so if we're looking at the observation, one could say, we look here, the faces and the vertices are always, the faces and the vertices are always less than the edges. Yeah, see here, 4, 4, 6, 6, 8, 12, 12, 20, 30. So we always see that. Now, we couldn't always say that there's more vertices than faces because the pyramid shows us that it's 4 and 4. Okay, so something else we could say, how about this? Could we just say that the dodecahedron has the most? I mean, that's still an observation, right? So it says it has the most faces, vertices, and edges. So we could say that. That could be our second one. Let's look. Okay. So it says here, I'm going to go ahead and expand this. There are some interesting relationships between the number of faces, edges, and vertices in all their platonic solids. For example, a number of edges is always greater than the number of faces. That's true. Another example is the number of edges is less than the sum of the number of faces and the number of vertices. So if we added the faces plus the vertices, that's always greater than the edges. And there is a relationship that can be expressed with an equation. Can you find it? If so, write the equation to represent it. Okay, so let's look at what they have. Okay, so we have these 2. They gave us 2 examples. Let's see if they work. So this says that vertices on the first one, that vertices plus the faces minus 2 equal the edges. Well, let's see if that works. 4 plus 4 is 8, minus 2 is 6. Okay, that does. 6 and 8 gives me 14, minus 2 is 12. Okay, so we see that does work. All right, we could say this, but now what about this? V plus F minus E equals 2. Okay, so now I'm 4, 8 minus 6 is 2. 8, 6, 14 minus 12 is 2. So that works. And then we say here, if we do that same thing, this works. Okay, so it's a trick question. It's just each thing its own question manipulated to how you best see it fit. All right, so let's do this. Let's go ahead and try to get split screens again so that we can write. Okay, write an equation to represent each situation. So we know that blueberries are $4.99 a pound. Diego buys B pounds of blueberries and pays $14.95. Okay, so if we were to figure out his pounds, remember, he said that it was $4.99 a pound. Do we know how many pounds he bought? No, that's B. Okay, but we do know that the total amount he pays was $14.95. That was on slide 13. So there's our equation for 13. So now we know that blueberries are $14.99 a pound, and Jada buys P pounds of blueberries and pays C dollars. So now we know on 14 it's still $4.99 a pound, but now Jada buys them and we don't know how much she spent. So we would replace that $14.95 with a C because we don't know. On 15, we're going to get even trickier, that they're D dollars a pound, and Lynn buys Q pounds of blueberries and pays T dollars. So now we know that we don't know how much they are a pound, that's D. We don't know how many pounds we bought, that's Q. And we don't know how much we paid for total, and that's T. So there's another equation. So now we've replaced it each time with a variable. Here was a variable, now we added 2, now we're all 3. So now on 16, I look here and it says that Noah earns N dollars over the summer. Maya earned $275, which is 45 more than Noah. More than. Remember when we talked in class the other day? More than means I'm adding. All right? And she's making more than Noah. So we have to add to Noah's. Okay, we wouldn't add to Maya's because Maya's the one who made the most. We got to add to Noah. So I'm going to take Noah, which is N. I'm going to add the 45 because she's more than that to get what Maya makes. Do we know what Maya makes? Yes, 275. Okay, 45 more than Noah. All right, let's go to 17. Now we know that Noah earned V dollars over the summer. Maya earned $45, which is which is $45 more than Noah did. So now we still know that Noah earned, we don't know what he earned, right? He's our V. But we still know that she's $45 more. So more than, we'd add a 45, and she earned M dollars. So there's our equation there. And now to put it all together with all 3, okay, we have Noah, W, okay, which is Y dollars more than Noah did, plus Y, and that's going to equal X. Now, you could have wrote those at home just practicing. Could you have said, it's N equals 275 minus 45, or a V equals M minus 45, or a W equals X minus Y? Yeah, you're still manipulating, but at the same time, you're going to get the same answer. So you could have wrote those both ways. All right, so we look here. How are these different? And how are they different? When we look here, the main difference for me is, let's see here. This right here is a one-step equation. I'm dividing by 499 and I'm done. We're done. These are one-step equations. So really there's no difference. We see that we're adding a variable each time, but at the end of the day, it's still one-step equations and those simple equations. Now, let's get into our car prices. So a tax on a sale car in Michigan is 6%. A dealership in Ann Arbor involves miscellaneous charge of 120. Okay, so what we need to know is a charge. Charge, what am I going to do with that charge? I'm going to add, subtract, multiply, divide. So we know at some point we're going to be adding 120, yeah? And we know that we've got the original car price. We might not know what that is. In this case, it says right here, the original car price is $9,500. So we have that. And we also find out our sales tax is 6%. And then the total is T. So we know that T is going to be our equal, right? That's going to be our total. So we could put the T here, or we could have put it at the other end. It doesn't matter, but we know that total. So we're going to say what the total is. So we know the total is this. The original price of the car, right? $9,500. Now we got to find that sales tax. How do we find that sales tax? That's right, we multiply and find 6% of that. So we're going to add the sales tax. And that sales tax is 6% as a decimal. Remember when we have a decimal, we take it, we move it 2 to the left, add your 0. So we're going to take 0.06 times 9,500 to find our sales tax, plus the 120 miscellaneous charge. Now let's see it. The easiest way to do it is to write it in words. So does the total equal the price of car plus the sales tax and plus the miscellaneous charge? All right, so we are good there. We are good there. 21. All right, let's look here. It's a 6% sales tax. Involves the 120 charge. There's several quantities. We see that. Write a description or write an equation to describe the relationship. So the main thing now is instead of the 9,500, we're going to input the new 14,699. So now it's still T equals 14,699 plus that 6% of the cost of the car. And we want to make sure that we're doing that right here because we've got to find that, and to get that sales tax so that we can add it into the total. Now, again, I told you, if you would have had this and this equal T, that's okay. That's okay. It can go as long as they're on, we don't cross anything and add it to the other side of the equal sign. We're good to go. Okay. Now we know, they've changed it up. So using this, we now know the total price. But what we don't know now is the price of the car. The price of the car. We don't know what that is. So now we've got here the price of the car plus that 6% of the total price of the car because we don't know it. But 120. But then now we do know that in total we paid $22,480. So there's my new equation for slide 22. And again, this was slide 21, and this was slide 20. Okay, now let's look at 23, and notice the trend, what they're doing, they're taking things away from us so that we can get this right. So now we have the total price of the car, P, plus still 6% of that price. Okay, we still are adding the 120, but now we don't know what that total is. T again. So now again they're giving us another one. Okay, slide 24. Oh, now we see that the total price of the car is the original car is $9,500, We don't know the total price. The sales tax 6%, and a car purchased that involves 120. Okay. What would the new equation be if we were to find the sales tax on the car, on the R percent, and the miscellaneous charges of M dollars? All right, now this is tough because what I'm about to tell you is this. It's not already a percentage. Okay, so that R, we don't know what that is. So if that's 12%, we're going to have to do something to that R. So really, guys, we know that the price is 9,500 plus. Now, instead of looking like it did up here where it'd be 0.6, okay, we got 0.6 because you took the 6% and you put it over 100. So we're going to have to do that same thing, the R over 100, so we can turn it into a decimal. Then you're still taking it times that 9,500, and that's still going to give you, oh, I'm sorry, we wouldn't add equal, okay? We would say plus the miscellaneous, and the miscellaneous is no longer 120, it's M, so that we can have T, okay? So to clarify on that, get new paper here. For number 24, okay, we took the price of the car, which again was 9,500. We had the rate. We didn't know what that was, but it has to go over 100. That's how we turn a percent into a decimal. We take that times the 9,500, which was the original amount of the car. We don't know what the miscellaneous charge, so it's M, and we add all of those together, and it gives us our total. Yes, I'm going fast. If you need to slow that down and process it, feel free to pause it and to back it up. Okay, so now we look here. Okay, write a new equation if the tax on the car sales is R, and we just did that. I'm sorry. So basically, we just did that. So here, okay, same kind of thing. We're taking that and we're manipulating it. I'm going to go through this for the sake of time. Okay, but here again, guys, what we know is this. All right, so for 27, if we didn't know the price of the car now, it would still just be P plus R over 100 times P, the price of the car. Okay, and then the miscellaneous charges are M. You're going to add your miscellaneous and get T. Okay? So now that we see this, we could use numbers or letters to represent those quantities in a situation. When might it make sense to only use numbers? Guys, that's going to be something that is always going to vary. Okay? Maybe it's the temperature that day. It's always going to be something that, hey, that's what you're inputting to see what your output is, and vice versa. It could just be the total. All right? And did I say that backwards? When might it make sense? I'm sorry. So that was for letters, when it varies. When I'm using here, when might it make sense to only use numbers? When we know that's set. So for example, that tax rate, when we knew the tax rate was 0.06, it's not going to change. We're going to take that times 0.06. Okay? Think about back last week when we used the Celsius formula. We're always going to be 5 over 9. That's what we're taking at times. All right? Those are things that never change. When we heard the phrases a quantity that varies and a quantity that stays consistent in this lesson, describe what they mean in your own words. I'm going to say really simple. Vary, it's a letter, okay? Or we know them as variable. We're going to sound like smart individuals. All right, when I see a constant, you hear constant, that is the number. It's not going to change, okay? It's consistent. It stays the same. All right, right, give a situation of a quantity that varies and a quantity that stays consistent. Okay, I can tell you right now a quantity that varies. Okay, that could be the class attendance. All right, the class that attends there, that's always going to vary based on all of those. And then a quantity that stays consistent, guys, just like that. When you had that miscellaneous charge to do that, or if you have to go somewhere and there's a fee up front, okay, there's a fee up front like an entry fee. All right, that's going to stay consistent, so that's going to be constant. It's not going to change. All right, the shirt colors. The school needs to make t-shirts for its 75 members and sets aside some money in their budget to pay for them. The members of the choir decide to order from a printing company that charges $3 a shirt plus a $50 fee for each color to be printed. Let X represent the number of colors on the shirt. Let D represent the total cost in dollars. Okay, so now we know this. Do we know how many shirts we're going to buy? We're going to buy 75. All right, right? We're going to buy 75. So we know here, this is number 32. We know that X is the colors. We know that D is the total cost. Now that we know that, we can write this. So we could say that D equals $3 a shirt. Let's say that S equals shirt. Let's write it like that first. So now we know that that's going to be 3S plus the $50 per color. So that would be 50D, right? I'm sorry. We said that X, and that's going to equal D. So that is where it is when we don't know the number of students that we're going to use. Hey, fixed cost right there, the 50, because we're using a number, it's always going to be 50, the charge that we use for that. The variable right here, the X. Now that we know that it is 75, we could say this. 3 times 75 plus 50x. That works out just as well. Okay. Which quantities do you think will vary? Okay. That's my letters. The D, the total cost, because that depends on this. What's not going to vary? The $3 a shirt and the 50. Okay. Anytime there's the numbers, we do that. All right. That is section 2 in a nutshell. Please make sure that you're reaching out to your teacher if you are struggling through this video. We'd be more than happy to help. Have a great day.